First, it's important to note that maximizing your stride length is an important step to improving your skating speed. To do so, we must take a look at triangles. When one leg is fully extended, your stride forms a right triangle like this. It is also important to note that the two shorter strides of a triangle, the legs, cannot add up to be greater in length than the hypotenuse of the triangle, because if this was so, the triangle would not be able to form. In your skating stride, you are working with a fixed hypotenuse, which is your leg, in meaning that, sadly, you can't make your leg longer or shorter. Therefore, the more you bend your knee, the longer your stride will be, in a direct proportion. One slight problem occurs, however, if you sit down too low in your stride, as it takes too much work for you to complete a stride, and your legs will strain. So sitting with a knee bend of less than 90 degrees, which is the optimal knee bend, causes you to fatigue extremely easily. But sitting with a knee bend greater than 90 degrees means that you are not getting the most out of every stride, making 90 degrees the key to maximizing your stride length, while also refusing to minimize your stride speed. Yet, this knee bend is not only important for the power in your stride and your stride length, it is also used to maximize your balance. Since the knee bend brings you lower to the ice, it also brings your center of mass lower to the ice, and this lower center of mass makes it harder for you to tip over, thus greatly increasing your balance. And with this increased balance, and the lower center of mass, it is also much harder for you to be pushed off the puck because you are in a much stronger stance. Now, we should also take into consideration the formula in which stride length times stride speed equals skating speed, which means that we cannot just look at our stride length, and we must also maximize our stride speed to become a fast overall skater, especially since with a longer stride comes a slightly shorter stride speed and vice versa in another proportion. Therefore, a slightly shorter recovery in the stride, like only bringing your feet to under your hips in this example, actually provides an advantage as it eliminates the glute flexation part of the stride that is seen in this example, which can only use your hips and smaller muscle groups as compared to the parts of the strides after your feet have come from under your hips and continue making their way out. Thus meaning that the glute flexation part of the stride has less power than the remainder of the stride, and therefore if you have to eliminate any part of the stride, it is the one that is worth eliminating. Yet one can only rely on their stride speed so much, as a human can only move their feet up to a speed of 7 meters per second, and once you've hit that speed, the rest of your speed must therefore come from maximizing your stride length and other biomechanical advantages like getting a greater force when you push out from the ice. Now that we have covered speed moving in a straight line, let's take a look at crossovers. Crossovers are used to get around a circle as fast as possible, and they are set up in a way that makes that even more doable. In the crossover, there are two pushes, the stride push and the X push. The stride push, as it sounds, works like a normal stride, but the X push uses the outside edge to propel the skater more towards the center of the circle. This push is used to half the distance needed to get around the circle, as it keeps you moving in the right direction, and eliminates the need for excess strides, which would make you slower, as seen in the C cuts around the circle. Next, I think it is important to discuss the blade when we discuss hockey skating. The hockey blade is made up of two edges, the inside edge and the outside edge. Between these two edges lies a semicircle, and the gap between these two blades is critical for skating. They can range from quarter-inch radii to half-inch radii, with shallow hollows, which are the larger radii, allowing you to sit on top of the ice more and glide better, and deeper hollows, or the smaller radii, allowing for you to cut into the ice better, creating more friction, which allows for better edges, but also happens to take away from pure skating speed. This design of the blade is specifically meant to allow for friction when the player wants it, but also to eliminate it when it is unwanted through the turning of the foot, and it also allows players to choose how much friction they want where when they choose their hollow depth.